budget variance happens in 48% of the projects. Now this slide could look very familiar to project managers particularly, because these are the standard reasons or broad reasons why projects fail, right? Lack of requirements, clarity of requirements, scope of requirements keep changing, and then you have the resource related issues, and then the planning wise, the estimation, insufficient accommodation of buffers, right? Now the point is, particularly for project managers, they don't have the luxury to state any of these reasons, right? They are there to be able to proactively manage these issues, being able to identify these things, sense these problems ahead of time, plan for it, and then make the project successful, right? Now how do they do it? So the best way to be proactive is to have a strong risk management policy, right? Now this is an interesting figure given by KPMG, which states the risk management approach of project managers, right, throughout the life cycle of a project. So I mean, this figure may not necessarily be accurate. It changes from case to case and company to company. But broadly speaking, we see that there are the risk management itself is one of the areas that is not too very strongly done in many projects. That's a reflection of this slide. So many cases, almost 85% of the risks are kind of left open, and they are kind of handled in multiple ways. Now, broadly classifying these risks, we can classify them into 4 different buckets, right? So one related to the vision, the system itself, what we've been trying to build, then the project related aspects, the team, finally the resources. Now, the business risk, schedule risk, and risk associated with the resources, as well as the team competency, team related work risk. Now those are, if you look at, pretty much homegrown for the project managers, right? And the areas of these risks are pretty much common across all the projects, and the level of best practices that can be shared is very high. Even if you go to say project management professional kind of a course, it talks a lot about the best practices applied on these 3 areas, right? But the 4th area, which is the technical and quality risk, is the most gray area among these 4, particularly from a project management standpoint, because this is kind of a black box for a lot of people, and it's not straight away to identify and do a great risk management in this area. And so many other external factors have to be contributing here. And the other important factor is the other 3 risk areas are pretty much self-impacting, or it may impact just 1 or 2 other areas. But a problem here with the technical and quality risk can affect the overall business. The project can get jeopardized. It could affect the team's competency, because the team should be competent enough to resolve these technical challenges. And finally, the schedule may also go for a toss if the technical challenges are going to be encountered in the project. So this is going to be the most crucial area, and people will have to focus more. Now, what do these risks constitute of? When we talk about technical and quality risks, one is typically underestimating the technical complexity of the system, right? So there is a difference between a requirement which states, okay, I want a booking form, a booking page. A requirement like this versus, now I want a flight booking form which is going to be operating 24/7, which is going to be accessed by thousands and thousands of users concurrently, and I want a great performance, and the backup of the system should be clear, right? You see, there are so many things that are getting added on compared to what was initial version of it. I want a booking form, right? So many times people just go with, okay, it's just a booking form, let me go ahead and probably put few hours for it, right? So underestimating the technical complexity is one factor. And then how do you manage system complexity itself? How do you manage the various requirements, the various configuration that needs to come? Because in the process, you don't want to end up with a code that is too clumsy, that is too difficult to manage down the line, because that's going to give you another headache from a manageability point of view. And then focusing on the extensibility, testability aspects, the architecture itself should be stable, right? And the system not being able to scale up, meeting real-time conditions, and performance issues that may pop up within the product or the application, right? So if you notice all these keywords that we talk about, they all boil down to one important aspect, which is the non-functional requirements of project. Because all these things, if you look at, are pretty much common and can be applied to any kind of a project, any kind of an application, right?